everyone. It's 2 minutes before 4 p.m. Welcome, everyone. As always, please type if you can hear me. I see that somebody has already typed, so thanks for that. Is the sound nice and clear? Excellent. Thank you so much. Good. Let's give the other participants another 2 minutes, and at straight 4 p.m. we start. So it's 4 p.m. Exactly to the second. Hello, everyone. Thanks a lot for joining. It's great to have you here, and thanks a lot that you take 45 minutes of your time on a Monday afternoon, shortly before going home. It's fantastic to see that so many people have logged in into a special team with AWS well-architected. Well-architected means that you already have something, or that you already plan to do something with AWS. So it's not anymore pretty basic as we had it the last week. So the last week we looked at how an AWS account is structured, what the elements are, what the compute and database things are in the AWS account. And this week we are going a bit further. So we want to make sure that we do the right things when we deploy resources and workloads into AWS. So for those of you that have not been here the last week, I see some faces that haven't been here the last time. It is recorded, so you can go back to the URL that you have received in the invite, so that you have the opportunity to watch the recording again. And we do also record this session. So if you do not agree that this is recorded, please log out now. Because of the new marketing regulations, the EU laws, we have to tell you that. Actually, nobody sees that you are logged in, but if you type something in the chat window, people can see that you have participated in this webinar. So for those of you that don't know what this is all about, that you have logged in just about curiosity, I will give a very brief introduction about COVID and myself. And for those of you that have already heard it last week, please apologize. It has been said who we are as well. So COVID is an advanced AWS consulting partner. So we have been around for probably 5 years now and got certified on an advanced level back in July, which are only very few AWS partners in Switzerland are actually consulting partners, advanced consulting partners, and we are one of them. So the agenda that we run through today is we look at the well-architected framework, what it is all about. I give you a quick overview, and then we look at the why. Why are we doing things in a well-architected way? And then we go deeper, looking at the 5 pillars, and at the end we talk about the principles, and I will also show you how a well-architected review is done. So if you have done an implementation well architected, you may want to review. There is a set of questions that you can run through to really get at the end like a report that states that you are well architected. Oh, by the way, if you have a question, you are all on mute. Please just type into the chat window. I will look at that, and I also have colleagues looking at that so that we can answer those questions. And if you really want to speak, I can also unmute you. Just type that into the chat window so that we can listen to you what you would like to ask. But easiest is if you type the question into the Q&A window. So it runs for about 45 minutes. I try to stick to 40 minutes talking and then about 5 minutes of Q&A. And if there are no questions, you will have 5 minutes back of your time. Good. Who is Copit? I briefly started that, and I will keep it brief this time. So we are an advanced AWS consulting partner. We focus a lot on AWS. But we also do containers and Kubernetes. It's a big topic for our employees as well, and also automation. And then obviously with these cloud native things, there's also some cloud consulting involved. Our CEO is very keen on IoT. We also have an IoT dashboard, an IoT application developed on AWS, and we are in total 13 employees in Zurich and St. Gallen. So to myself, I have been 3 years in Australia and learned there a lot in the cloud native world, DevOps, serverless, AWS, all of it. So that was a super interesting time. And already in 2015, I did quite a bit of AWS and DevOps things, which was very early on there. I do have 8 AWS certifications on the pro level, the DevOps and the Solution Architect Pro. So I'm not only a talking robot, so I can also implement those things. And also I have done a Kubernetes admin certification, which is also quite difficult to achieve. And I do AWS, GCP, and Azure hands-on things, but my main focus is on AWS and Kubernetes these days. Good. What is well architected? Why are companies doing well architected? So as an introduction, well architected is really a set of best practices from AWS so that you can implement your workload on a well architected according to best practices from AWS. So AWS has developed the well architected framework probably over the last 8 years or so. I can't really remember when it was announced. Werner Vogels announced that probably 8 or 9 years ago, so pretty early in the game. And that was because they have learned so much when they looked at their provisioned AWS accounts from customers. So they have seen that a lot can go wrong. And what they put together is a set of best practices so that not everyone has to learn and experiment from the beginning. So when you build according to the well-architected framework, you are sure that your account is well-architected, is according to best practices, so that you don't overpay, that security is right, and all these things. So that's the aim of the well-architected framework. So here you see that in text, basically it is guidance for developers, architects, finance, and SysOps as they design, build, migrate, and optimize workloads. It's really about building and doing the right things on AWS. More minted to us as Copit, because you can go to and open an AWS account and you can start building your own AWS account. And quite often customers come to us and ask us, we do have a problem with XYZ feature security group or feature RDS, or the AWS bill has gone through the roof, and please help us to optimize that. In many of such cases, we recommend to clients that a well-architected framework review is done. So that really is looked at what is implemented, what do you want to achieve, and is it implemented in the right way? And then we run through the review and give a set of recommendations so that an account can mitigate it. But obviously, you can also use the well-architected framework when you start to build your AWS account. So from the beginning, so that you don't have to re-architect, so that you architect from the beginning that the costs are low, that it's secure, well-automated, and all of those things. I have looked in my 6, 7, 8 years of career in the AWS space, probably 200 to 300 accounts. So I haven't counted, but it's a lot of AWS accounts that I have looked up. Already in Australia, I had the opportunity to look at those accounts also before, and you will be surprised what you see. So, for example, lately we reviewed one client, and they had the database opened to the internet, or another client had his access keys for the root account not well secured. So 700 days old keys for the root account, which is super critical, really dangerous. If something grabs that key and breaks into the AWS account, that will be expensive, data loss, and all of those things that you don't want to experience. And probably the biggest case is what I have seen in Australia. So one of our clients came to us, or it was a new client that came to us and told us, hey, my credit card is overcharged. I have in 1 month a $50K US dollar charge on my AWS account. Before I only had a couple of $100. What happened? And when we went through that account, we have seen that there was a lot of Monero miners running in those accounts. So each region was fully maxed with EC2 instances, big databases running, and they were churning away and mining Moneros, and another guy was paying for that. But that's all because it wasn't built according to the well-architected framework. So in that case, that particular person lost his access keys to the account. Some bad actor grabbed those and started in a well-automated way to maximize resource consumption to mine Monero. Really not a nice case, and quite funny discussions with AWS to get their money back, and it cost them a lot of time because their data was deleted, stuff that they didn't know what they should do with it, and quite a high bill at the end as well. So they had about 3 days of downtime and $50K of AWS bills racked up. Not a funny place to be in. So the well-architected framework, if you implement correctly, such things should not happen. I don't say it doesn't happen, but it should happen quite less frequently. So what is the well-architected framework? It is the 5 pillars. We will go into those 5 pillars in a minute. Then it is design principles, which are linked to those 5 principles, to these 5 pillars. And then it's a set of questions that come with an application to do a well-architected framework. So these are the 3 areas that we quickly will run through so that you get an insight what the well-architected framework is. And when we talk about the pillars, I will also give you examples on these pillars and what needs to be done there to do it correctly. Obviously, you wouldn't do that if there are not benefits to it. So when the benefits of doing well-architected, on implementing well-architected, but also reviewing well-architected is you think cloud natively when you do that. So you really try to use cloud native tools like microservices, like databases that are fully managed, or even Lambdas for serverless. So you try to push as much as possible onto AWS shoulders so that you don't have to manage it yourself. When you build according to best practices, you should understand the potential impact of the risk. So you will list the risks, you will have visibility of the risks, and you will mitigate those risks. So if you have to achieve a certain RPO and RTO, you design according to these RPOs and RTOs. And if you can't, then you at least list the risks that you have. Sometimes you have limitations from the software, so you may not be able to run it multi-AZ or multi-region or in a fully managed way, but then you document it so that another person that sees that knows why that decision has been taken. And when you build well-architected, you build it in an automated way. You build it on, for example, CloudFormation or Terraform, so that you have a very consistent approach to architecture, but also to reviewing architectures. So because you build in infrastructure as code, you have it well documented from the beginning, and then it's very easy to review those things at another time. Here it gets a bit more into the depth. If you build it really according to those 5 pillars, you can build and deploy much faster. So if you build on CloudFormation or on infrastructure as code, you can spin up very easily new environments or new AWS accounts or new feature branches or do blue-green deployments because it is all fully automated and built in a descriptive way. Because you analyze the risks and you try to mitigate those risks, the risks should come down. And if you still have a risk, you have it at least well documented. So if something happens, that you know what to do. And then you probably make informed decisions so that you really have the stakeholders behind. For example, if you can't mitigate the risk, that you inform the stakeholders. So look, if X happens, we may lose 12 hours of data, and the stakeholders, they may agree to that. And obviously, you learn a lot about the AWS best practices, how you should implement, what the best way is. And if you haven't implemented in a best practices way, most likely if you have a support case, the support people will much better understand what is going on without asking a ton of questions because they don't understand what you have implemented. So there are quite a few benefits when you design according to the well-architected framework. So enough of the overview and why you should do these things. You probably want to know what is really in there. And what is really in there is these 5 pillars. And we go into a bit more details of these pillars, but these are the things that we are looking at. So operational excellence is really about monitoring, building in code, making sure that what you build is really there. So that is operational excellence. Security, that's very obvious, but that is super critical in an AWS account, because if you apply the wrong security group, everything is fully open to the internet. AWS is a public cloud, you need to know what you do. And it's not only about putting the workload into the right subnets and securing them correctly, it's also about applying the right controls, so for auditability and stuff like that. Reliability, you really want to have your applications available. And AWS has a great set of tools that you can use. And if you design it correctly, your application will be always on, or at least you won't lose the data if something happens. So AWS makes it super easy to have multi-AZ databases or VMs that can be shared across multiple availability zones, stuff like that. Performance efficiency is all about using the right instances. So and also scaling those instances when it comes. So you probably have heard of auto-scaling. These days you can auto-scale VMs and containers and serverless super easy. And more we can also scale databases. So for example, the Aurora databases in serverless mode, they can be very easily auto-scaled as well. That can save a lot of cost and also help a lot for the performance. So that if you have a spike, that the databases behind the workloads, the service behind can handle that spike in a controlled manner. And cost optimization is also a super big topic. Here it is really bringing costs down, controlling costs, so that you have the right controls in place, that you do the right things. And here it's really easy things that can be applied. For example, one of the best practices is to always have a budget, so that when you open an AWS account, you should always put in a budget. And the budget is not a hard thing, but it at least informs you if something goes wrong. So for example, if that client that I mentioned to you before had a budget installed, which is normal consumption, let's say about $500 US a month, he would have been notified immediately when he got hacked. So he should have been able to look at it very quickly. But cost optimization is also about bringing down costs. So for example, when your account is getting older, you probably have started with M3 instances, and AWS brings out new instances almost every year, so that you go in and upgrade these instances, that you get better performance, lower prices, and other features as well. So these are things that really help. And these two coupled, performance efficiency and cost optimization, can bring down costs dramatically. So for example, with autoscaling, if you know that you need 2 instances all the time, but during the day you need 10 instances. So it's super easy these days to write a script, like a function or whatever, that kicks in 8 additional instances at 8 a.m. in the morning, so that you have well-performing applications during the day, and at 7 p.m. in the evening, you deprovision these instances again. That's super easy to do, and that will have a big cost impact, because your majority of the instances are not running in a big time frame during your week. So it's just 5 days that you need high performance, and from 7 days and during the night, you don't need these many instances. That's a manual way of bringing down costs and also increase performance. But there are also obviously dynamic approaches, so where you can monitor CPU, memory, or connections that are coming in. A lot that can be done here for VMs, containers, and functions. When you apply the best practices to your existing AWS account, you will learn a lot, because it's not so easy, for example, to implement an auto-scaled application. So that will challenge you. And if you have it already, congratulations, continue doing that. And then it also pushes you to measure more, so that you have better dashboards, better metrics, so that you get a lot better visibility on what is going on. Maybe you don't know how many connections that you have during normal operations. When you do well architected, you will measure those things, so that you really understand your account much better. And if you know what you do, and if you measure, you can start to improve. You can bring down RPO, RTO at the same price. You can lower your consumption costs, and probably you learn a lot when you do that. So let's go into these pillars again. So we have talked about these a bit more. Now I want to give you some more examples of in those pillars here. So in the operational excellence, we really try to monitor well, and we really try to do automation well. So the aim in the operational excellence pillar is to really have all the things that make sense to automate, that they really are automated. So in the best case, everything is built in CloudFormation. Everything that is installed is installed via scripts, and nothing is done via UI clicking in the console. Really, everything is highly documented. That's the aim of the operational excellence area. And if you have it all documented, or if you have it all built in CloudFormation, you basically also have your documentation. The reason is you build it all in code, and when you build in code, you really know what is going on. In the security space, I have mentioned it before, a few things. So nothing out on the public internet. So you have private subnets, you have public subnets. In the public subnets, basically, are only load balancers and nothing else. You try to have all your databases, all your registries, all your queues, all your functions, and so forth, all in the private area. So that's a big thing in the security. So security is a lot about networking, and it's a lot about measuring things in the security area. More and more, we want also to monitor the security area. So, for example, enabling CloudTrail, enabling config, enabling guard duty. These are all things that should be done so that you really know what is going on in your account, so that the API requests, the data requests, all these things are locked, so that you see what is going on in your AWS account. And AWS makes it super easy these days to enable it. So, for example, guard duty is probably 2 lines of code, maybe 4 lines of code, and guard duty is enabled. And then you see if somebody from China or India or wherever is logging into your account, and that is not your usual pattern that a root user logs in from India. So then you get notified that you can do something, or guard duty applies artificial intelligence to your account. And config really records everything that is going on in terms of elements that are provisioned. So basically you see at what time did you have what database, what containers spun up, what load balancing configurations did you have, and how did they change? So it's comparable to a CMDB, and it does that all in the background automatic. You don't have to do anything, but if you need the information, you can go in there and really see what was going on. Reliability, I mentioned that before. With reliability, we really want to have maximum uptime, and if something happens, you want to be able to recover quickly. That is in the reliability space. Examples here, when you have persistent storage, really snapshot those things. You use RDS snapshots, EC2 snapshots, or other snapshotting technologies that are out there. It's built into these persistent storage layers, super easy to use, really use them. And when you do those snapshots, make sure that you have a good persisting scheme, so that you throw away the old snapshots that you don't need anymore, because it starts to get costly if you snapshot every 4 hours and you keep all those data, all those snapshots for years and years. So have here a good retention plan to take out old snapshots that you don't need anymore. So that's for reliability. Performance efficiency, I had here quite a few examples with autoscaling, but here it's also about designing correctly. So if you can put something into a container, put it into a container, but if it is a full-size application, you can't put it into a container, use a VM for that. So here it's also about doing it, choosing the right instance to provision those workloads correctly. And if there is a managed service and you can use that managed service, it fulfills your requirements, always use that. It offloads all those day 2 operations, patching, securing, monitoring, all these annoying things are offloaded to AWS. They do that for you at a great price. So the best example here is databases. Databases can be quite clumsy to set up for all the different databases that you may need for RDS and for Oracle and Postgres and MS SQL and so forth. And you need to patch those, and you need to back up, and you need to monitor, and you need to recognize when the disk is filling up. when you can use a managed service, it really helps to keep your back free of these annoying tasks. And cost optimization is, as mentioned before, using the right instances, using the right tool, and doing that regularly. So that's also why you see here a circle. So cost optimization is not something that you do at the day of implementation. Obviously, then it's super important that you do it correct, that you use the newest instance if you can. But also after a year, you should go back and see, is there a new instance? Can I upgrade? Can I use a savings plan? Can I use a reservation plan? When your instances are running all the time, use those savings plans to really bring down the cost. You can save 50% or more if you put these resources on your saving plans. And also shutting down instances, shutting down resources that you don't need. That saves a lot, because at AWS you pay every second where your instances are running, you pay, but if they're turned off, you don't pay. And databases can be quite costly. So, for example, for the dev and the testing environments, why don't you turn off these databases during the night? It can save you 50–60% easily. For example, for one client, we have built dashboards where people that have no clue about AWS, they can go in, turn on their databases, do their tests, what they want to do, and when they are done, they go again into that dashboard, shut down the database so that the costs can be saved. And with that approach, the client with his budget could use a much better performing database, so the tests run much quicker, the calculations that they need to do, because they turn off the databases. And when a database is turned off, you only pay the storage, and CPU memory and licenses are off your bill. So a real benefit and big cost savings can be achieved with doing that. To the design principles. AWS has structured that into two areas. So general design principles that apply to all of the pillars. And then we do have, for each pillar, we do have a set of design principles that we try to adhere to be aligned to the best practices. So general design principles. I pick here a few that make sense. So for example, when you do test systems, you should do that at production scale. So because you can turn off your test systems with the AWS function that they have seen before, you can very easily test them at the production sizing, at the production scale. And here it's also stop guessing about your capacity needs. Really look at those metrics so that you know how many requests are coming in, that you monitor these load balancers, and then that you can really size these environments according to the capacity that you really need. And the rest is also pretty important, but you can read them yourself. I don't have to repeat them here. Design principles for operational excellence. So that's probably the most important one. So everything that you do, you should do that as code. Meaning you don't go into the UI and click the things together. That's okay when you are learning stuff. When you do that the first time, you do that in the AWS console, so that you understand how the future of product works. But if you put it into production, then it should be in code. Because code is repeatable, you can store it in a Git, so that you see who has changed what. You can do code reviews. You can really handle your infrastructure as code, and that's the biggest aim. And if you do that, you have a documentation. So you basically document everything. You don't have to go ask the guy that has clicked together. You can go into Git and see what was really there. Here is a lot of great things. Try to make small and reversible changes. So if you have everything in code and you do a small change, and if something fails, you just reverse the change. You apply the old CloudFormation template, and the change is reversed. So these are really great design principles that you should focus on. And AWS makes it really easy to implement according to those design principles. Design principles for security. So identity obviously is super important, and it should be strong, meaning if you have accounts, these accounts should be highly secured, no access keys lying around. If you have to use access keys, you rotate them on a monthly or 2 monthly basis, because an access key that is published to anywhere can have a real big impact onto your security. So really make sure that you have those accounts strongly identified and really MFA put on everywhere. And then on the root account and in the admin account is a real must. So there is no account in AWS that has admin privileges that has no MFA. So that's a real no-go. Any accounts without having MFA, like the mobile phone MFA tokens, Google Auth and so forth that you put in. Then you try to apply security at all layers. So really meaning you put it at the foundation, at the network, at the application, so that you can work towards a zero trust environment. And you automate it. You test these security things. So you make sure that nobody has put in an open to the world security group. And here AWS is really great as well. So for example, the config tool that I mentioned before helps you automating these security best practices. So if somebody puts in an IAM user without an MFA token, you get an alert. If somebody tries to disable CloudTrail, you get an alert. If somebody puts in a security group that is open to the world, you get an alert. So that is really a really good help. And that is obvious. You should encrypt at transit and at rest. When we build things, we encrypt everything at rest. Super easy. It's one flag and everything is encrypted. It's really cool what AWS offers here. And you should prepare for security events. So do these game days where you prepare, where you simulate, so that you can go through those checklists that you see that that your security plan and checklist really works when you have an incident. Reliability, here is a lot about testing and automatically recover from failure. So you design for failure. If something happens, you recover quickly from it. So put those required recovery principles according to your RPO and RTO requirements into the system. Auto-scaling helps a lot as well with reliability. So if an instance fails, it is replaced automatically. That goes into cattle versus pet philosophy. That is really easy to implement at AWS. And here again, a lot about automation. So if you need to do changes, you use the automation. If you need to do a fleet-wide command, use the runbooks that are there. Use automatic patching. All these things are there for you. Just need to implement it. Performance efficiency. Yeah, here serverless architectures obviously is super helpful with performance. So with serverless architectures, it's automatically auto-scaled. It's automatically event-driven. And if you can't use serverless, use containers as the next step. And here use stateless applications without the scaling and multi-AZ designs. And then you have performance and reliability solved at the same time. And that sounds really nice. Democratize advanced technologies is basically just give everyone access to these things so that they can design their applications with these features and functions in place. And for cost optimization, the design principles start to get people into the consumption model mind state, so that they really understand when an instance is started, it costs. When an instance is shut down, it doesn't cost. So that the autoscaling and the turning off of features are really first nature to everyone. What do we have here? Yeah, I mentioned that before. Use managed services to reduce cost of ownership. That really helps. Comparing a self-managed Postgres database, comparing that to RDS Postgres or even Aurora Postgres, Aurora is so much better. AWS does that really well. Let them manage those things for you. You don't have to be an underlying Postgres expert. What you should care about is the data inside, the functions, the routines, and AWS won't do that. You really can focus on the higher level things and stop worrying about disks and performance and CPU memory and stuff like that, or even patching and security. AWS has that all fully automated. Make use of those things. Good. So we are coming slowly to an end for the presentation. Here you see when you have something implemented and you want to review, there is a set of questions that you can run through. And the well-architected framework has for each pillar a white paper. You see that later on. And in each white paper, there is a lot of questions relevant to that pillar, but you can go through to understand if you have it implemented. You can do it yourself. These white papers are public. There is even a tool in AWS. It's called the Well-Architected Framework Review Tool, where all these questions are listed. So you can open the tool, you can read the question, put in an answer, check accordingly, and at the end you get the results and the set of recommendations, what you should do better. And here you see how those questions are structured. Some best practices aligned always to those questions, so that you see what the context is behind the question itself. Here you see the well-architected framework is really well documented in a great white paper. It's probably 150 pages. It's quite a big thing. And then for each pillar, you have another white paper that lists all these questions and gives recommendations. And there's also free training, obviously. You can find more information under that link, or if you Google for AWS well-architected, you'll find heaps of information how to do it correctly. Good. So this time I'm pretty much on time, 1 minute over from the allocated time. So anyone having a question? Yes, there's somebody typing. Good. Thanks, Nicole, also for your feedback. Any general feedback that you want to give me? If you need anything, just reach out to us. We are here. We can do these well-architected reviews for your account together with AWS, so we can do them as well. Just reach out. We are here to help. If you need anything, reach out to hello@codebits.ch. We are here. If you have any question, send us an email, chat to us. You can find us on LinkedIn as well, so that we are here. so that we can help you on your journey. And the next month we will have another webinar. So this one here is wrong. I forgot to update that. So I can't remember what the next webinar is, but it is at the end of September. When I stop this webinar, you get automatically an invitation, and we are looking forward to have you on the next webinar, which is together with AWS. So Simone will be there as well. Simone Pomato from AWS. I think we will look at serverless stuff or CloudFormation stuff. Some really interesting topics that Simone and I will co-present. So thanks a lot for your time. It was great to have you here. Talk to you in September. Thank you. Goodbye. Mark just mentioned it. It is 21st of September for CloudFormation. Thank you so much, folks. Have a great week. I'll talk to you soon. Thank you and goodbye.